Okay, today we're going to be talking about something called piecewise functions. And essentially a piecewise function is nothing more than a function that looks like one function on the left of a particular point or a particular x value, and it looks like a completely different function to the right of that particular x value. So let's just take this very simple piecewise function for example. And what you want to do with all of these problems is basically you want to figure out the ordered pair where one function starts and the other function ends. So let's just take 0 and plug it into the parabola, and you'll get 0, 0. So does it start or end there? Well, let's just take a look at this. This parabola is to be drawn for all x's less than 0 or left of 0. So that means that it's going to end at 0, 0. Now this linear function is going to be valid for all x's greater than or equal to 0. So that means it's going to start at 0, 0. So if you have your worksheet that has, or your notes that have the 12 parent functions on them, you should know that the parabola is going to look like this. And we're going to put an open circle right there because it's less than, or it doesn't say less than or equal to, just less than. And then we are going to graph a linear function starting at the same point. So this open circle is now closed in and we have a nice linear function. So these graphs are going to look very weird. It looks like a parabola on the left and a linear function on the right. All right, in this second example, we have an exponential function, e to the x, for x's greater than or equal to 0. So let's once again plug in 0 into this function, e to the 0, or any number to the 0 power. And by the way, e is one of the two constants that you want to have memorized in math, 2.718. The other is pi, 3.14. So don't think that just because e is a letter that it represents a variable. It is actually a number. Now, so you have a number to the 0 power, that's going to be 1. Anything to the 0 power is 1. So 0, 1 is where this exponential function is going to begin because it's x greater than or equal to 0. And 1 over x is the reciprocal function, and that's going to be x less than 0. So you can't plug in 0 here because you can't divide by 0. So all you can do really here is draw your reciprocal function, and then on the other side you will draw your exponential function that has a closed circle there and up there like this. Now, just so you know, the exponential function really looks like this, coming around there like that and up there like that, but we're only using a piece of it, so we are not going to be using that particular part, just this part here. Okay, here we have this third example, and we have x is greater than or equal to 1. We have a linear function with a slope of 2. And then we have a parabola that's been shifted up 2 units for all x's less than 1. So let's plug in our 1 into our function. 2 times 1 is 2, minus 3 is negative 1. So this has an ordered pair of 1, negative 1. And then we're going to plug in 1 here. 1 squared is 1 plus 2 is 3. So 1, 3. All right, so let's go ahead and graph our linear function first. So this is going to start, because it's greater than or equal to 1, so it's going to start at this point. So over 1, down 1, and we're going to put a closed circle. And we're going to make the slope positive. So we're just going to go up from there, and that should be good enough. It's just a sketch. And then we're going to go to 1, 3, and we're going to put an open circle there. So how about we put an open circle here, right there. And this is a parabola shifted up 2 units, so that's going to be the y-intercept. And you're just going to come down there and draw the other part of the parabola. Notice we're not going past 1 because after 1, the linear function is the function that you have to draw. All right, here we have this fourth example, and now they've given the function x absolute value of x plus 3, and this is valid for x is less than or equal to 0, so left of 0. This is an absolute value function shifted up 3. So we're going to go up 3, and we're going to do an absolute value function, which is just a v. So we're going to just come down here, and we're going to put a closed circle there, and we're going to stop. And then now we have the natural log function for all x is greater than 0. Notice it's not greater than or equal to because you cannot take the log of 0. So it's going to just be this regular natural log function. All right, so once again, piecewise functions are not very difficult to sketch. Okay, example 5, we have a square root function that is shifted left 4. And remember that when the plus 4 is inside of the grouping symbols, it's a shift left. If it was outside, it would be shifting up 4. But this is inside, so it's going to be left 4, and x is less than or equal to 0. So let's plug 0 into our function and figure out where it stops. So you plug in 0, 0 plus 4 is 4, root 4 is 2, so 0, comma 2 is where this function ends because it's valid for x is less than or equal to 0. So we're going to shift 1, 2, 3, 4, and we're going to draw a square root function, and we're going to put a closed dot because it's less than or equal to. And then we're going to, so this is up 2 units, and then we're going to draw a cosine curve for all x is greater than 0. We have to remember that the cosine curve starts at 0, 1, and the sine function is the one that comes through the origin. So this one is going to look like this, and it's just going to be a basic cosine curve. Okay, in this last example, we have a cubing function that's been shifted up 2 units for all x is less than or equal to 1, and we have a linear function for x is greater than 1. So let's plug 1 once again into our formula to get our point. So you have 1, comma 3, and this function is valid for x is less than or equal to 1, so this is going to be the ending point. So let's go 1 and 3 and put a dot there. So the normal cubing function goes through the origin, has a little slide there, but this one is shifted up 2 units. So this one's going to look something like that, and it's going to end at 1, 3. Now we have the linear function. I'm going to plug 1 in here, and we also get 3. So 1, 3. And this is going to have a slope of 2, so it's going to be a steep problem, and steep line rather. So you have a cubing function and a linear function, and they both end up starting at 1, 3 and ending at 1, 3.